All right, so we're going to continue with a little bit of our math review. We did talk a little bit about just basic algebra, number manipulations, etc. And the last what we're going to take a look at now are, again, some mathematical operations, but we're going to now introduce some symbols that we're going to see frequently, not just in math specifically and physics and chemistry, but we're going to see this in your fire courses as well. And this specifically is going to relate to how we compare different numbers. So some of these you may have seen before, others it may be new stuff. So the first one here is a symbol that looks like this, and this means less than. So for example, we can say, if we compare two numbers, we can say 15 is less than 30, right? The way that I used way back when to help me remember this symbol kind of looks like an L if you tilt your head a little bit. So 15 is less than 30. Another way to think of this is that it kind of also looks like an arrow and it's going to point towards the smaller value. Okay? So this number here means, or this symbol here means less than. Well, the opposite, this would mean more than. So for example, we can say 30 is more than 15. Again, it points towards the smaller of the values. We can combine, well, before we combine, we know that's an equal sign. Okay, so two dashes across. So, we usually use those when we have different equations. So we can say, for example, 5x plus 3 is equal to 20. And we can go through and we can solve for x like you've done over the last week. Now, we can kind of combine the first three of these here, the first one and the last one. So for instance, we can say less than, with that little line underneath, this means less than or equal to. So we can say x, for example, is less than or equal to 5. So that means x can have values. It can be less than or equal to 5. So it could be 5, 4, 3, 2, or 1. Right? And similarly, if you look at the opposite of that, so more than or equal to. So more than, so we can say by the same token, x, I'm just making this up, right? So x is more than or equal to 5. So that means x could be values of 5, 6, 7, 8, and I'm just going to say dot, 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 and continue till you run out of numbers, which you never will. So those are some of the symbols that you're going to see. We're going to use these when we start doing calculations related not just to chemistry, physics, but also when you get to your fire calculations down the road. We're going to see these symbols being used quite frequently. A couple other ones that we're going to come across are the following. So very often, and we use this symbol in chemistry a lot, is you'll see a triangle. Right, what that triangle means, it can have a couple meanings depending on the setting. This can mean the change in something. So for example, we can say triangle T, and this would mean change in temperature. And by the way, this triangle here, it's a symbol, a Greek symbol. It's called delta. And that's how you read that. So if you have triangle T, we would read that as delta T, and delta of anything means the change in that thing. In this case, it's a change in temperature. And when you determine the change in anything, okay, delta of anything means the final value minus the initial value. Right? So where you end up, subtract from that where you started. So for example, if the temperature in a room changes from 20 degrees Celsius to let's say 55 degrees Celsius. And then we're asking what is delta T, the change in temperature? Well, then this would be delta T here would be the final temperature. So if T, by the way, so temperature here, we're abbreviating that as T. We're going to take the final temperature, we're going to minus the vapor temperature. So the way that we would do that, we would write that, we would say T and then subscript final. Actually, that's the final temperature minus T initial. T subscript initial, that's the initial temperature. And then you have to look at your question here and you need to extract that relevant information. Okay, so it tells us the temperature changes from 20 to 55. So we end up at 55. That 55 is my final temperature. I'm going to subtract which I started 20 degrees C. So we do a simple subtraction there. We end up at 35 degrees Celsius is the change in temperature. And you can determine the change in anything, a change in mass, change in volume, change in whatever, by applying the same general principle, same general rule. So this triangle, when you see it, at least for now, it means delta, which means change in something. I'm going to very quickly show you where you will see that triangle again. And when we get to the chemistry stuff down the road, we'll revisit it. So I'm just going to say down here. So also, this triangle can mean heat when seen in a chemical reaction or chemical equation. Okay, so for example, and again, this may look completely foreign to you right now if you haven't gotten into the chemistry side of things, but if, for instance, we had some ethane, or let's say some propane. So propane has the chemical formula. So there's 3 carbons, and then there's hydrogen. H is hydrogen, C is carbon. So C3H8, there's 3 carbons and 8 hydrogens that can react with oxygen in the air. So propane, in the propane grill or whatever. O2 here, O is oxygen, and oxygen exists as 2 of these O's stuck together. Oxygen gas. Okay, these can react with each other to make, we can make carbon dioxide, which is C and 2 O's. And we also get water, so 2 hydrogens and an oxygen. Okay, and we can see a little triangle down here that in this case, this triangle doesn't mean change in something. Here in the chemical reaction or chemical equation, which is what this thing is, here it actually means heat to get the reaction going. Okay, so, and you'll see this a lot in science. Certain symbols mean slightly different things depending on where you see them. Again, the triangle here is a good example of this. Okay, let's take a look at another symbol that we're going to see a lot, and that is the symbol that kind of looks like an E. And that symbol, just like the triangle above that meant delta, this here means sigma, uppercase sigma in a particular language, and sigma here means the sum of. Okay, so and to get the sum of a series of whatever data points or things, we're going to add those things together. So add the values together. Okay, so this sigma, that means the sum of something. So for example, if we wanted to find, or let's say, you know, the mass of the 3, let's say, people in an elevator. Oh, and we're going to say we have Tommy, who is 59 kilograms. We have Jenny, who is 45 kilograms. And then let's say mile, who is 63 kilograms. Okay, and then we're asked, given that information, so what is the sum of their masses? What is the total mass of people? Okay, so in the elevator. So what we're trying to find here is the sum of the mass. And that would be the mass of each of those people. So the mass of, hey, we can use the same kind of notation, the mass of Tommy. So mass of subscript Tommy plus, mass of Annie. Like you can maybe just use the initial if you wanted to, plus the mass of, let's say, 5. If you had more people, you would just add them together. In this case, we just have 3. It's going to be 59 kilograms plus 5 kilograms plus 63. Maybe stick them together. You can use a calculator if you want. Do it in your head if you're able to. I'm not going to waste my energy trying to do that in my head. I'm going to use my calculator. So 59 plus 45 plus 63 is going to give me 167 kilograms, right? So that's the sum. My symbol, let me rewrite that. A symbol here, sum of the mass of all the people in the elevator would be 167 kilograms. Okay, so these symbols, sum or sigma, delta, change in something, and then all of these mathematical symbols up here. We're going to see these a lot when we get to chemistry, physics, but also require specific calculations down the road.